Good evening. You're all very welcome. My name is David Fitzpatrick. I'm the Dean of Engineering, the Principal for the College of Engineering and Architecture. And you're very welcome to our Engineering Open Evening. You've already had a chance, I hope, to talk to some of my colleagues around the specifics of their programs and what they do. And what I hope we'll do over the next while is to give you a broad introduction to engineering in UCD, the program structure, what we feel makes it different and why you might be interested in it, and then to get an input from the student perspective, the graduate perspective, and also to look at the career opportunities. So I'm very pleased to be able to say that I'm not the only person speaking this evening, and I have three people joining me. I have Nicola Fortune from the UCD Career Development Centre, Catherine Wachter, who is an electronic engineering student, and Colin Keogh, who's a graduate student studying for a PhD at the moment. So, without further ado, I shall try and master the technology. So I would ask you just to make sure your phones are off, and if an alarm bell rings, then the exits are out the back where you came in, or down the exits here at the lower level. If you see any of the four speakers running in a particular direction, maybe just follow them, and they can guide you out. So let me talk a bit about engineering in UCD, and I have two short videos when they load. The first one is from Engineers Ireland. You may have seen it on TV a few years ago.
Will you come with me?
Across bridges and railways.
To feel the Atlantic's wave power.
To brave new worlds. From the rudder to the engines.
To making monsters.
These things are there for me and you.
From purifying water with reverse osmosis.
To stopping cells dying.
From apoptosis.
Multiplayer
Online.
gaming.
Clearing minds and saving lives.
These things are there for me and you.
Chartered engineers, bringing dreams to life for me and you.
So although engineering is very visible around us, and we think we know what's involved when we use products and other services, what maybe should be the one-word summary of that short video is pervasive. Engineering is everywhere. Everything that you do, use, or consume is going to be involving an engineering process or engineers at some point in that process. This is my favorite particular cartoon, Dilbert, you may know, and let me just play it and then talk about it.
I've been sitting here for nearly a minute without entertainment. Change the battery in the remote. The one on the left. The one on the left? Well, that's just spooky. Not really. I have the knack. The knack? For technology. My mom says I always have.
I'm worried about little Dilbert. He's not like other kids.
Never work with technology. Let me go to plan B.
Just come out of it.
Yeah. I don't have the knack, obviously.
I've been sitting here for nearly a minute without entertainment. Change the battery in the remote. The one on the left. The one on the left? Well, that's just spooky. Not really. I have the knack. The knack? For technology. My mom says I always have.
I'm worried about little Dilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
It's perfectly normal. Kids take things apart.
Ooh. The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical, and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer.
No!
There. Don't blame yourself.
Will it go away over time?
It might, but pray it doesn't. If an engineer loses the knack, the results can be devastating.
And in further news, you might want to get out those...
Thanks for filling in for our regular doctor on such short notice.
I was in the neighborhood.
So maybe you like taking things apart, maybe you're interested in mathematics, maybe you're interested in finding out how things work, maybe you have the knack, maybe you don't. But part of the engineering program is really to help you develop that skill set and that mindset, that curiosity to find out why things work the way they do and then how to improve them, how to build on it to make things better or to make new things from the fact that you understand the fundamentals behind what currently exists. There was a comment in there to other social ineptitudes. We deal with that as well. We help you develop communication skills, team working, intercultural, multicultural, multidisciplinary skills, all of which are a core part of what industry wants to see when they're employing young graduates these days. So not only are you looking at technical excellence, but you should also be considering about what other aspects of myself am I going to develop within whatever program I decide to take. So why choose engineering in UCD? The university is ranked in the top 1% of the universities in the world. We believe we have a world-class engineering education. We have a phenomenal range of engineering degree options, which I'll run through shortly. And if you follow the 5-year track within our engineering programs, you will have a 6 to 8 month internship in the second half of your 4th year. That, in particular, is a key differentiator between the programs in UCD and other engineering programs around the country. Through that internship program, we've developed significant links with major employers. In fact, many employers will use an internship as a way of pre-screening and pre-vetting potential future employees. Within our overall structures, you can also follow other subjects to a limited extent. So you have some options, electives, that you can choose from across all the subjects in the university. And finally, our programs are accredited by Engineers Ireland or the IChemE or the Institute of Materials, for example, depending on the program that you're following. These are the range of degree options we offer. We don't quite offer everything from A to Z, but certainly B, biomedical engineering or biosystems and food engineering, through chemical, civil, electrical and electronic, energy systems, engineering with business. Engineering with business in particular is one where you develop your major specialty in a particular engineering discipline, such as civil or electronic or mechanical, and then take a minor in the business subjects in your 4th and 5th years. Material science engineering, mechanical engineering, optical engineering, and structural engineering with architecture. So you can see from that list, some of them are core, what we might understand as core traditional engineering subjects, others are newer developments within the professional. So what is the structure of our engineering program? Effectively, you have a common first year, so every student will take the same subjects and the same core subjects in their first year. There are a few options in the second semester to let you sample different parts of the program that you might be interested in for your further degree. At the end of your first year, you make one choice and you decide which main stream you're going to move into. And then at the end of your 3rd year, you have another choice. You can choose whether you want to stay in your current major stream and graduate at the end of 4 years with a bachelor's degree, a BE, in whatever that major is, or to change into the 5-year ME stream and then to move into that final 2 years of the engineering program. So gradual specialization, 2 key choices to make during the engineering program. A key question, at least in Ireland, is how many points do I need? And this year, the minimum entry points was 509 points. The average, I should say, of first-year engineering this year is about 555 points. So students entering engineering in UCD are achieving phenomenally good grades and levels within their Leaving Certificate results. You do have to have meet a couple of core requirements. First, it is in mathematics, a minimum of H4, and you need to have one laboratory science, minimum of H6 in chemistry, biology, or physics. In your first year, as I said, there's a common core curriculum, and the primary objective of that is to bring everybody up to about the same level. Some students will have come in doing physics and not chemistry, or vice versa. Some students will have come in just doing biology and neither physics nor chemistry. Some students will have come in doing all the sciences plus applied maths. So there's quite a wide variety of students entering first year. We need to try and give them all a baseline level of knowledge across the sciences and mathematics. Alongside the core science mathematics, you also have a couple of engineering modules to try and give you an idea of what you're going to be moving into. One of those is creativity and design, teamwork-based, problem-solving, and running through a number of problems through the semester to produce specific design solutions, which are then judged both by the internal faculty who are delivering the program, but also by external companies or sponsors who may come in with a particular idea they'd like to get your ideas on. There are a number of ways in which we'll deliver the program. Traditionally, of course, as the lectures, you have somebody like me standing in a lecture theatre like this, delivering the core content, the key elements of information you need to know. You need to take that information and then use it in a practical sense in a laboratory, or to work in smaller groups in tutorial settings to work through more detailed problem sets and so on, to make sure that you understand the fundamentals and that you can apply them in the way that we think you should. Within the modules, you'll carry out a number of design exercises or projects. They might be individual or group or team-based, alongside class assessments, midterm tests, and then at the end of semester, a final exam in that particular module. Most modules will have a final exam. Some are done just on the basis of continuous assessment through the semester. Moving through the various disciplines in the School of Civil Engineering. Civil engineering, a decade ago, took a bad rap because the construction sector in Ireland, I should say, collapsed. Civil engineering worldwide is a dominant engineering discipline, and there are career opportunities not just in Ireland but around the globe. When you think of the major infrastructure developments in terms of roads, railways, water, environmental, and so on, civil engineering can contribute to all of that. Structural engineering with architecture is one of our specialty programs where effectively you are a structural engineer, but you also have subjects taken from the School of Architecture, and that gives you an understanding of what the architects are trying to achieve, and you effectively become an intermediary between structural engineering and the architecture profession, and meeting a demand there where the architects would like to build some amazingly complex structure, but actually physically you cannot make it. So trying to interpret and work together to get a design that is realizable and implementable. Biomedical engineering, which is one of the growth areas nationally, involves taking traditional engineering approaches, particularly in mechanical engineering, electronic engineering, and material science, and applying that to problems that arise in the human body. So the ones that we're most familiar with are the very traditional areas of medical devices for total hip or total knee replacement, or stents, or pacemakers, and so on. But that's now moving into areas such as deep brain stimulation, where you're trying to control Parkinson's tremor by creating impulses in the brain through a medical device that's designed and implanted into the individual. So combining mechanical and electronic engineering is a strength of the program here in UCD, in that we have expertise, world-class expertise in both of those discipline areas in biomedical. Mechanical materials engineering, again one of the traditional core disciplines, is looking at how you can create systems and design and manufacture those to produce devices, components and products of worth. So again, you're looking at robotics, communications. Traditionally we'd have a strong reputation in internal combustions, now moving into energy capture and use in electric vehicles and so on instead. Energy systems engineering draws on both electrical and mechanical engineering, and helps you look at how you can capture and then use available energy sources across a range of application areas, including automotive, aeronautical, and IT. In electronic and electrical engineering, you study essentially the same curriculum for the first 3 years and then divide out into the disciplines specifically of electrical and electronic. And electrical, of course, is to do with the generation and distribution of electrical power, and electronic is to do with the computing power and communication side of that sector. And in UCD, our core strength in electrical engineering is the integration of renewable energy into the grid. So if you take wind power, for example, it's not that long ago when the international experts said that you could never generate more than 40% of your demand from wind power and use it usefully on the grid. Research in UCD demonstrated that was clearly not the case. And now if you look at some of the data for Ireland, we're occasionally reaching 80-90% of wind power supply within our national grid. In electronic engineering, designing circuits and systems that feed into the telecom sector and the computing sector is a traditional level of expertise within UCD, and we work with and provide graduates to all of the major multinationals in that space. Chemical and bioprocess engineering is essentially about taking raw materials and then converting them through some sort of transformation process into a usable and useful product. And traditionally that would have been the petrochemical industry. Nowadays that's much more likely to be in the biochemical or the biopharma space, particularly in Ireland. And so there's very strong demand for graduates from the biopharmaceutical sector, for example. A characteristic of our program is that we offer students the opportunity to study abroad for a semester or for a year, usually in the third year of their study. And you can see from the pin drops some of the universities that we have relationships with. The majority of our students travel to countries that are English speaking. Some will travel to the continent depending on their language skills. And we're happy to support students to travel to partners of equivalent standing as much as possible. I mentioned the internships or the professional work experience. These are some of the companies that we work with. And you can see they cover the sectors from medical device, telecoms, automotive, consultancy, and so on. And really, the only requirement we have for our internship is that the students work as a professional engineer in a professional environment. We don't mind if they're working in a research lab or in an industry space, and whether that industry space is based in Ireland or based around the world, as long as they can demonstrate that they're working as a professional engineer. That's the key requirement. The internship lasts 6 to 8 months. Well over 90% of our internships are paid, and paid pretty well, I believe. And as I mentioned earlier, companies will use internships as a recruitment tool to assess people for future employment prospects. Quite often students will come back into their final year here, having completed their internship, with possibly a final year project to work with the company on, and quite often some offer of a job should they complete their degree to a particular level, for example. Where do our graduates go? This is a small snapshot of where they work, and you can see all the leading multinationals, a few ones you mightn't expect to see, particularly in the automotive sector, Bentley and Ferrari, for example. But really, engineering graduates can travel the world and do travel the world and find employment across all sectors, not just in core engineering areas, but in many multinational spaces. So, what do I think we can offer? The widest range of courses, accredited degrees, world-class academics, study abroad opportunities, very strong employment prospects, and very strong salary levels on graduation, which then progress quite rapidly, and I'm sure Nicola will talk a bit more about that. Alongside what we offer within the academic environment, UCD also offers an incredibly wide range of clubs and societies. Now, when I mentioned at the start, part of what you need to think about is how you want to develop yourself. That's another aspect that we will encourage. We want students to develop their interests in clubs and societies. The engineering program is demanding, takes a lot of time, but you will find engineering students are heavily involved in all of the clubs and societies around the university. We strongly support that. Finally, I should say that UCD and engineering and architecture in particular have very strong student support services, whether it's in terms of finding your internship place or having people to go and talk to when you hit problems, whether they're academic or personal. And that support infrastructure is part of what we've developed and feel is a core to how we help students progress through the programs when they hit issues. I'm going to stop there. I'm going to hand over to Nicola. Thank you very much. We will have questions at the end rather than now. Thank you. Yeah. Okay, people at the back, there are seats still down around the sides. I think if you can maybe come and try and find a seat. There's some here in the front as well.
Oh, that is your water. Okay. So, good evening, everyone. My name is Nicola, and I do not have a knack at all. So, I won't be trying to play you a video or anything because the knack is working, which is part of why I really enjoy working with our engineering students. So, as David mentioned, I am a career and skills consultant here in the university, and I work with our engineering and architecture students in particular. So over the next 10 minutes, I was going to talk to you just very quickly about careers in engineering, as well as kind of focusing a little bit on what you can do to prepare yourself for a career in engineering over the course of your degree. So in terms of kind of what is an engineer, I think David already kind of covered that. I'm not going to force audience interaction on you and ask you to tell me what an engineer is. But I suppose I would see an engineer as somebody who's very practical, somebody to be a problem solver, somebody who likes to turn ideas into reality. So these are some of the kind of core aspects of being an engineer to me. So you'll find engineers in lots of different sectors, and again, kind of I'm not going to repeat what David was talking about, but I'm sure you guys already are fairly familiar with the different places you might find an engineer, whether that's kind of working in pharmaceuticals or working in electronics, working on a wind farm. There's a huge range of different places you might be. In addition to that, though, you'll find that there's actually quite a lot of crossover and mobility within engineering, because those core traits of an engineer and what you actually learn through your training as an engineering, so they actually kind of carry you through in a number of different ways. So as well as finding engineers working kind of into traditional areas, you'll also find them in areas like finance and management consulting. So there's loads of different ways you could actually kind of progress throughout your degree, and obviously you're going to kind of learn as you go along through the Omnibus programme. You'll have a chance to try things. But as you develop, you'll develop lots of other things as well. So you're going to develop your analytical skills, you're going to develop your teamwork skills. Obviously I'm going to guess a lot of you have quite good numeracy skills already. So these are very attractive in a number of different sectors. So in terms of kind of last year's class, as you can see here, the figures are very positive, and a lot of the employers are exactly who you'd expect to see, so people like Pfizer and Arup. But you'll also see there some of our top employers include people like Accenture and First Derivatives. So there actually are a huge number of opportunities out there for students who actually are graduating with an engineering degree. So it's not just one path, it kind of opens up a lot of ranges. Although obviously, again, you might already not know what you want to go into right now, or you might have a really set idea. But what we'd hope to do is work with you over the course of your qualification to kind of filter that out. So in terms of, I suppose, engineering as a graduate career, I have a very easy job in a lot of ways. It's all very positive news. So I'm going to guess a lot of you already know some of this. But engineering as a graduate degree, as a graduate career, would actually have the second highest salary. So it would start at 30,000 kind of as an average salary, and obviously you'd be progressing then as you go along. Engineers are obviously in demand with different engineering firms and companies, but actually engineers are in demand across sector. So 34% of just general employers in Ireland have said they want to recruit engineers. So that's actually a huge kind of field to consider. So that being said, obviously it's a great picture, but we actually don't want people to become complacent. So obviously we want you to be competing for the most attractive opportunities. We want you to have the widest range of options available. So we want to work with you to make you as competitive as possible. So I suppose that's really what I wanted to talk to you about just over the next couple of minutes. What can you do while you're actually doing your qualification to kind of prepare for that career? So that kind of career that's going to last for a much longer time. So from the very start, you'll actually be meeting me. So you'll meet me in week 1, in fact, of your degree. So kind of week 1 and in fact week 2, you'll meet me again. So there will be people working with you throughout your qualification. And what we'll be doing is trying to highlight the different ways that you can actually develop so that you will kind of, I suppose, are able to present yourself as this perfect applicant later on so that you have this whole range of opportunities available to you. So when we say perfect applicant, there's lots of different things that could mean. From an employer's perspective, there's obviously certain things they're going to be looking for. So some of them are obvious, so they're going to be looking for academic achievement, so they want to see that you are achieving kind of within your modules and within your degree, so they're going to be looking for certain levels of achievement there. But that's not really enough. So obviously to differentiate yourself from your classmates and from other people who've done similar qualifications, you're going to need to bring a little bit more than just the academics. So we'd hope that you'd also gain work experience, that you'd be able to articulate the transferable skills that you gain both through your degree as well as through your extracurriculars, that you actually get a little bit clued in so that you understand the roles that you're applying for as well as the sectors, and also that you're engaged with your community. So it's really about becoming this more, I suppose, well-rounded person as opposed to just focusing on one thing, and that's part of what we'd like to work with you on. So the whole way through the process, you might be kind of approaching this in different ways right from first year. So at the very start, what we'd like to see is students engaging with the UCD community, joining clubs and societies. So obviously if you're joining clubs and societies, we'll hope you find them fun, whether that's the Trampolining Society or a LEXOC, but as well as actually enjoying them, you'll have an opportunity to develop your skills. So you're going to have a chance to actually maybe take on different opportunities for responsibility or different roles. Maybe you can help to organise events as part of these clubs and societies, as well as to try things out. So joining clubs and societies, possibly volunteering, so you might want to consider doing volunteering. Any form of work experience is always going to be wonderful, so the more relevant the better, but just being in any kind of environment where you're actually learning how to be employed to a certain extent is going to stand to you. Being open to different things, so whether that's things like learning a language, so you're going to have the opportunity to take electives throughout your time here in UCD, and we'd encourage you to consider maybe broadening things out a little bit and thinking about what other opportunities I might have later on. So if you do want to do an international opportunity later on, you'll have a little bit more opportunity that way. In first year, obviously, you're going to be starting to maybe think a little bit about the qualification you're doing, as well as kind of how you're finding it yourself. So from the very start, we'd hope that you'd be a little bit reflective and you'd think about what you're enjoying, you'd pay attention to it, you'd think about your transferable skills and how you're developing them. So actually just to start reflecting on the experiences you're having and kind of think a little bit about what you can take from them. And then from the very start, we'd like you to be engaged as much as possible and actually being aware of the different opportunities out there. So starting to research career opportunities. So it's a long kind of process until you finish, but we want you to start from the very start. So as you progress during your degree, we'd hope you'd continue and I suppose get a little bit more serious about some of those elements. So we'd be hoping you'd start to attend employer events. So we have lots of employer events on campus, careers workshops. So for instance, I'll be running regular careers workshops on the basic things like CVs or interview skills, but also things like maybe how to network more strategically. So there's lots of different things like that you can take part in. Also kind of at this stage we'd be hoping you do a little bit more research on how graduate recruitment works. So whether that's coming to talk to us or doing your own research or attending events, finding out what's out there. Building your network is always going to be an important thing because it'll give you a chance to explore things. So the more people in your network, the more people you can ask questions of. You can ask them questions like, so you work in this field, can you tell me what your normal day is like? So networking both online and offline, that's something we'd like to see you doing, whether that's joining professional bodies or getting involved in different kind of events. And then really considering different opportunities, whether it's things like doing an internship or doing job shadowing for a day even, just to try to understand the sectors a little bit further. So we'd hope that you wouldn't leave everything to the very end and you'd be doing this bit by bit as you go through your degree. But as you move towards the end, obviously you're going to be thinking about things like getting your CV up to date, getting your interview techniques, practicing mock interviews, actually attending events and also applying for things. And we're going to help you through this whole process. So in terms of the supports available in UCD, there's a very wide range. I just picked some things out here again. So we do 4 different recruitment affairs throughout the year. So we have them starting in September. We also have employer presentations running pretty much throughout the year. So a lot of different employers, obviously they want to recruit our students and we want our students to have a chance to meet them, to ask them questions, to find out more about what's going on. So you'll be invited to employer presentations. You'll also have access to things like vacancies portals. I have my wonderful internship manager colleagues are here this evening, so we have internship managers who will work with you if you choose to do the ME programme to help you prepare yourself to apply for academic internships. So there's a process around that, obviously we're going to support you through. As well as that, you'll do different kind of careers workshops, so some of them will be taking part as part of your qualification, so it might be in a class, other things might be on lunchtime, so you might kind of want to decide what you want to attend that way. As well as careers workshops, we do individual meetings. So the individual meetings will be coming to the Career Development Centre to talk about maybe your career plan, which direction you're going to go in, what could move you forward. But they're just some of the supports available, I suppose, with the Career Development Centre in particular. But as David mentions, there's actually a really extensive range of supports and resources on campus itself. So there are really a lot of opportunities that you have to develop professionally. So that includes things like joining the clubs and societies. So we have a huge number of clubs and societies, as well as we have volunteering in the community. We have international opportunities. So there's a wide range of ways that you can actually develop through the university, and obviously we'll work with you as you do that. So that was my really fast kind of whirlwind through the different supports and how we'll work with you during your degree. I'm happy to say I'm going to be outside with my colleagues afterwards. So if you have any individual questions and you want to have a chat with me about the different kind of paths you might be following, or if you have any specific questions or general, please just come over and say hello. But with that, I might pass you on to one of our current students. Okay.
Hi everyone, so my name's Catherine. I'm currently in my third year in electrical and electronics engineering, more specifically towards electronics. So first off, I'm going to talk a little bit about how I ended up here. So I wasn't actually going to choose engineering at first. Up until about 6th year, I was thinking of doing forensic chemistry. So a completely different field. But one day I walked into my physics classroom and my teacher said to me, "So which engineering school are you going to?" And when I told him I wasn't planning on doing engineering, he sat down with me and explained to me why I should do engineering. And the idea hadn't even occurred to me. Like, it wasn't really something that was pushed in my school, and I was always more looking towards science. But once he explained that to me, it all just kind of makes sense, and I figured, yeah, you know, that's really something that I want to do. I've always loved science, maths, just solving problems and that sort of thing, and that is something that almost every engineering student will tell you. It's just, you know, we're all solving puzzles and stuff like that. Like, it starts from when we're little, like we're always taking stuff apart, just like the Dean was explaining earlier. And I think, like at first I didn't even know, like, okay, I'd chosen engineering, but I didn't really have a specific pathway in mind. And if I did, it would have been more geared towards like environmental engineering and that sort of thing. I actually almost went to another university where I would have started straight off in environmental and civil engineering. As you can tell, if I'm now in electronics, that's not what I'm planning on doing now. So I think the general first year really allowed me to sort of, you know, try different things and pick a degree that I know I'll enjoy, rather than just something that I imagine might be fitted for me, but I haven't really tried yet, so who really knows. And in the end, it did really work out. I really enjoy it, and I also discovered that I really like programming as well. So that's something that I discovered in first year, because we have a bit of an introduction into computer science as well. And that is something that's heavily tied into electronics, even though I am planning on going more into hardware rather than software. It's obviously always tied together, and it is something that I do enjoy as well. At this point, you're probably wondering a little bit where my accent's from, and if you're thinking somewhere around Dublin, you'd be quite wrong. I'm actually from Strasbourg, France, and moved to the US when I was about 16. My mum's American, so that's where that came from. And so I've only moved here now since first year. Next question is usually, how did I end up here? So I was always planning on going back to Europe after I went to the US, and I was looking at different countries. I almost ended up in Scotland, but looking at Ireland, the first obvious choice was UCD. Like, the engineering program just stands out. Like, when you're looking online from an outsider's perspective, you automatically see UCD. And I think the sort of large campus that we have here and all the diverse, you know, opportunities in clubs and societies was something that I thought was very appealing. Despite the large size of the campus, I do have to say, like, you very quickly kind of find your way around. Like, the first couple of days, it's kind of daunting and it's huge and you have no idea where you're going. But we do get eased into it very quickly, and like, we have a whole orientation program with peer mentors who are like students in second year who kind of help the first years, you know, get around in the first couple of days. So that really helps with just getting used to it. And once you kind of find your place, like in such a large campus, you do kind of, through the extracurriculars and within your own program, you find a small group of friends, and you know, it feels a little bit smaller, but you're still, it's nice to have a large campus where you're not always going to the same building every day, and you know, you get to move around a little bit. The general first year, like I said, was something that was very beneficial to me, and even though I didn't automatically see the huge value in it. By the end of it, I definitely knew that that was something that if I hadn't had, I would have had a completely different degree. And the wide variety of specialisations, like the Dean explained earlier, is something that we do pride ourselves on, and is like, obviously once you've picked your stream, you kind of forget about the other ones, but it is very important because we're all very different and each one of us kind of finds their own place in that. So being a student in UCD, obviously that's kind of what I'm here to talk to you about. So kind of on a day-to-day basis, every week we have about 15 hours of lectures, and between 3 and 9 hours of labs. It really depends on your timetable. You can't really set a number of hours per week. It just kind of varies. Those labs are obviously part of our assessment, so it goes from about 30% in some modules up to even 100% on our labs, because they are a very important part of engineering. And then we do have exams at the end of each semester, so you'd have 12 weeks of classes, a week off for study, 2 weeks of exams, and then you're on break for either a month for Christmas or three months during the summer. Since we don't have that many hours, really, like 15 hours a week isn't really that much, so we do have a lot of breaks throughout the day. So it goes from either, just 1 hour off for lunch, or sometimes you have like 3 or 4 hours off between your lectures. Some of us go to the library and study, but a lot of the time there's a bunch of other things to do. Societies will often have coffee mornings. If you plan your week properly, you can probably get breakfast every single morning on campus. So that's something that is, like, if you're off at 10 in the morning, you can easily, grab a coffee with one of the societies and chat to people. And then in the evenings as well, all of the societies will have most of their large events in the evening, because this way they don't have to worry about everyone's timetables. Same thing with the clubs. All your team practice and stuff will be going on in the evening. As well, kind of on a practical aspect, in first year you'd be mostly in the science building rather than in engineering, but then once you specialise, you're either in engineering if you're doing electrical and electronics, mechanical, chemical or biomedical engineering, and then civil and structural would be in the Newstead building, which is slightly farther off. It's still on campus, but it's just not quite in the middle there. Obviously, a huge part of being in engineering is our projects, so here's just a couple of ones that I've worked on. So creativity and design is a module in first year that was already mentioned. So this is my team in first year. So every week we were set a problem that, almost like a general area of problems that we had to find and then solve. So one of the weeks we had to go to a playground, talk to people, figure out something that was wrong with it and solve it. So that's us at the playground there. The most interesting project we had in that was actually a 4 or 5 week long project with Engineers Without Borders. So we actually looked at a town in Peru where there was issues with their water management, their waste management, their transport, their heating. It's still developing, so we had to find cheap solutions to really large scale problems, and that was really interesting. And just working towards that and doing all our research, it was 5 weeks is a while to work on a project. And the winning team on that actually went to London to compete against other universities as well. Also in first year, we've a mechanics challenge which changes every year. So our year we had to build a structure that could, that was as light as possible and could lift the heaviest weight it could. So that was sort of our one there. And not only did we have to design it, we also had to calculate all the different forces involved. So it was really interesting to, rather than just being given a structure and just analysing it on paper, we had to find the structure and analyse it ourselves. So it was really our own little project there. And we had to figure out the weight of all the different components, where the centre of mass would be and all those kinds of things. And then they actually make a whole evening out of it. Everyone just competes, and we get to see everyone else's projects. Another project, I think that was the year after us, was they had to build a bridge out of paper. They could also sustain a weight, I think, on top of it. Then we've a couple of robotics modules in electronics. So this was a robot that we made in first year. The goal of that module was actually to build a robot to play robo-rugby. So we basically spent the entire module playing with Lego. It was great fun. So the robot just had to collect as many balls as possible and bring it into its score zone. So we had to design mechanically how our robot was going to work, but also program it, which was a really good introduction into programming that was a little bit more fun than just a regular computer science module. And we also have robotics going on as an extracurricular. So the Electrical and Electronic Society, ELECSOC for short, has a robotics club going on every week. So that's some of the sumo bots that were made, and we also had a little competition going on with that. So there are a lot of opportunities if you're interested in that, and not necessarily even doing electronics. If you're doing mechanical but you still like robotics, you can join the club and work on stuff with that. And they do have other resources like 3D printing if you're interested in any sort of tech. Like we have quite a wide range of options with that. Project management was a module that I took last year, so we actually learned how to manage a project rather than just get it done as fast as possible. So that was really interesting, even though it wasn't necessarily engineering related, and it was with other faculties as well. But it was interesting to really see how we're meant to do it, how to work in a team rather than just winging it and seeing where we go. And then this year I'm working with a group on the IEEE design competition. So the IEEE is the professional body, one of the professional bodies for electrical and electronics engineers worldwide. So we were actually invited by one of our lecturers to a lecture at the Royal Irish Academy. So that's us there. The project is mostly going on next semester, so I don't have over much to say about it yet, but we'll be working on that soon, and we're actually working on, it's a very wide brief on just trying to make some form of circuit that helps people on a day-to-day basis. So it is really a wide range, but there's a lot of opportunities like this one. They do broaden a lot. Like if we hadn't mentioned this to anyone, we wouldn't have been invited to this, and it was actually a really interesting lecture. Then extracurriculars obviously are a huge part of UCD, and I'm involved in a lot of things. So first one there is Film Stock. So last year I was the graphics officer for the Film Society, and up there is their Lord of the Rings marathon that they had this year. So we were locked in overnight in the student centre watching Lord of the Rings. It was great fun. Then I also was part of the fashion show when I was in first year. I was actually on the marketing team. So I was taking photos, getting donations, all that sort of stuff, which was really interesting because it's something that I had never really done in school. So all of a sudden I was involved in a really large project, even though I didn't, I wasn't really high up in that hierarchy, but I did a good few things, and it kind of allowed me to see what it looks like to be involved in such a large project there. I'm the secretary this year for ELECSOC, and this year is the group at the Intel plant in Leixlip. So we do kind of sort of field trips almost to different companies, and like I said earlier, there's robotics club as well, and we bring companies in a lot. So each sort of faculty has its own society. There's MECSOC, ELECSOC, ChemSOC, biomedical. I can't remember what they exactly call themselves, but so every branch of engineering has its own society, and even outside there's a medical society, a nurse society, really anything. And the societies also get very specific. There's actually a higher powder society, that's one of the largest societies on campus, believe it or not. So really anything that you're interested in, like, there will be a society for it. I'm also a student ambassador, so that's the entire team there. There's quite a lot of us. So that's, I think, was a really good opportunity to learn to actually talk to people and stuff. Like, I wouldn't be doing this, talking to people like a huge group like this, if I hadn't done like small things like that. And then I'm also involved with the Women in STEM group. It's only starting off now, so there's actually a group in faculty, but now there's also a student group in UCD, and we're working towards helping, obviously, students in STEM, but also trying a bit of an outreach program to try to get girls in schools more interested in, science and technology and all that. And then what's next? So I'm planning on doing the 2-year masters here in UCD. So like was explained earlier, there are a lot of degree options. So right now I'm more or less set on doing the masters in electronic and computer engineering, but I haven't actually made the official decision yet. And like what I think was really good with that is, you start off your degree in UCD without knowing what you're actually graduating with, which is kind of strange, but I think it's really good because, you get to figure it out as you go. And I feel like every time I do a module on something new, I feel like, oh, maybe that would be something that I might want to work towards, or maybe that's something I really don't like and I'll start to steer my degree somewhere else. So you kind of figure out as you go kind of what you want to work towards. Obviously the 6 to 8 month placement in industry is something that's very attractive for us because we get to, take a little break from studying and learn kind of what it's like to work really in industry, and then come back, finish the degree, and then possibly have a job in the same company or not. Like if your internship didn't go well, you know that that's a company you don't want to work with, and that's just as valuable really. And as well with the Masters, it's good in the sense that you need the Masters to be a chartered engineer, so it's kind of, it makes that process a little bit faster, and you don't have to come back later and do your Masters. After UCD, well, it's really open. Like Nicola said, like we could end up working in one of these companies or really anything else in finance and IT and whatever we want. And like you can see in these kinds of companies, like they are really global companies, so you might start off in Ireland and end up somewhere completely different, which I think is something that is really exciting. So there you go. If you've any questions, I'll be outside as well after this, so feel free to ask. Thanks.
Hello. Hello everybody. So my name is Colin Keogh and I'm a graduate here of the undergrad, the Masters and soon to be PhD programs here at UCD. So I'm just going to talk a little bit about my experiences, what I've done, where I came from, that sort of thing for the next couple of minutes. So my background is I'm from a family of car mechanics. My father was a car mechanic, still is, in a small kind of independent run car mechanic shop, just him and then me during the summer. So I'd always been involved and exposed to kind of the building, construction, fixing things, engineering, machinery, that sort of stuff. So very, very early on, I developed a love of kind of technology, cars, vehicles, that sort of thing. And then it's no surprise to anybody that I ended up in engineering, truthfully. So as you can see, like an awful lot of people, these are me. Oh, isn't it lovely? It's supposedly me. It's the blonde one, maybe not. So, you know, as you can see, like an awful lot of people, I was always interested in Lego, Meccano, building things, construction kits, building blocks, and then cars and vehicles and that sort of thing. And what I tell people is, I'm still exactly the same thing as that. The building blocks just get way more dangerous, and then the cars just get much, much, much faster. But it's still exactly the same thing, and I've just kind of brought my experiences and my background into the field of engineering and changed it and developed a career that like lets me do what I'm interested in a way that's kind of slightly different to what most people do. So I'm from Braid, the nicest place in the whole world, as you can see. And I went to a school out in Braid, non-special, St. Killian's, great school. And I went there and I wasn't a stellar student in any shape or form. Like I wasn't 700 points top of the class, so I'm still not now. It's not going to happen. But it was nothing special. I was just kind of involved and engaged. I knew what I wanted to do. I knew I wanted to study engineering, and I knew what I wanted to do to get it. So any advice kind of academically I'd give to you guys is take the handouts to do it engineering. If you want to do it, find out the requirements you need and do whatever you can to get them. Anything beyond that's a nice advantage, but what gets you in, and you're good to go from there. So I did the Leaving Cert in 2007, I think. In 2007, and then I came here to UCD in 2007 on the higher access to education route, actually. So I had some learning difficulties when I was a kid, and the attainment rates from my school weren't hugely high. It was in a kind of disadvantaged area, so I came in as an access student. So access students make great students. I'd say that I'm one of them. It's so it's open and engaged to everybody, and truthfully I never had any issues or problems through. There's lots of support, there's lots of help, there's lots of advice, there's everything you need in the course of engineering. So I did an undergrad in mechanical engineering from 2007 to 2011 and worked on a whole range of different things. So these are just the product things, from designing kind of prosthetics and artificial hips, from design, manufacture, treatment, shipping, that sort of thing, from labs and workshops based on aerodynamics and airflow systems, design, lots and lots of designing simple things like turbines to get used to computerized design processes, and then more complicated things like this really complicated walking frame that we made that ended up being horrendously expensive and is never going to exist. But it's a nice photograph anyway, so things that could have been. So at the end of your undergrad, let's say, you'll do a final year project. So I decided I was interested in cars and automotive systems. I wanted to do a project on electric and renewable vehicles. And at that stage in 2011, I was full on petrol power, like Lamborghinis and Ferraris rule all. And then decided I want to show how bad for the environment electric cars are, and failed miserably. So everyone will have one eventually. They're just slow to come about. So what I did is I analysed them from the production of the fuel to the extracting of the materials to assembling the car to running them through its life cycle to disposing them at the end, for how much energy is used, how much emissions are created, how much water you use, everything from the beginning to end. From my perspective, to prove how bad they were, and I failed massively because they're really actually quite beneficial for the environment. So you live and you learn. I still don't have one though. So from that, I got myself, I talked my way into a job in BMW in Germany from a previous graduate of UCD. I happened to just actually meet him here at an event and followed him kind of, not home, but out of the room. I was going to say home, out of the room, and said, I'd love to work in BMW, and then we had a discussion, and then he offered me a job in BMW in Germany, working on what was the I cars at the time, the i3 and the i8, and I was all set and ready to go, and then decided I didn't want to go. So I didn't, so I came back to UCD, and I decided I'd do a master's, so I wanted to do a master's in energy systems. So I focused on energy systems, and I did an awful lot of work in renewable stuff. I had a focus, again, kind of to do with automotive. So I looked at electric vehicles, I looked at the production of fuel from biological sources, biofuels, that sort of thing, making fuel from seaweed, integration of solar panels, and learned an awful lot about the renewable energy industry and the traditional industry, again, through workshops and kind of classes and lectures, and got a great overview of the system, and then focused on an awful lot of different projects, but also some projects that people wouldn't expect. So I did some projects on nanomaterials and nanoscale manufacturing, making really small features for medical devices, building, modelling and imaging, production processes, vehicle assessments, and then my focus was mainly on biofuels, making fuels from sunflower seeds and seaweeds and that sort of stuff. So that then led me onto my final project for the Masters, which was I work with a large European Union project that was running at the time called Algae, and that was assessing the possibility of creating energy, fuel and materials and products from cultured algae, so seaweed and pond scum and that sort of stuff, creating and growing that and turning that into energy, food, pharmaceuticals, plastics, that sort of thing. And I worked with all the countries in green. I think it was like 8 or 9 countries around Europe. I had a great time working on that, and it gave me an opportunity to work on a large European project and really learn how to become like a real functioning, working professional research engineer. So I then decided what I was going to do, and these are some of the companies that I, at that stage, were talking to and was looking at and had an interest in, or some of my immediate friends went and worked at. So, a broad spectrum from all the consultancy companies, some automotive companies, aerospace, space companies, power generation, technology, an awful lot of everything. So you can see its scope is quite wide, and I think afterwards, I've worked with all of them, bar Ferrari in some little bit or other, and the Ferrari one really hurts, but we'll get there eventually. So I decided, again, I didn't want to leave. The place is lovely, look at that, isn't it gorgeous? Like, here on the UCD campus, every day is like that, just believe me, it's lovely, and it's an excellent place to work. It was a place that I could explore fields and look at problems and look at technologies and look at issues that I couldn't kind of deal with anywhere else. And I also have a personal problem that I'm kind of like a blackbird or a raven or whatever, magpie. I kind of like shiny things. I like new stuff, new technology, new solutions, new problems. And as you can see here, I'm easily distracted as well. Christ. This is actually at an German engineering conference. And I met the head of the German Engineering Association 5 seconds after that when I crashed into the German castle. But he really liked that. We talked about the friction on the wheels. We had a great time. So I was working then and decided to work as a research engineer. So I conduct research in here as an engineer in a range of different things. So as you would during an undergrad or a master's, you'll undertake research projects. So what I decided I'd do is work in research and do that kind of professionally. So I worked on a whole range of different products in different fields with groups like the EPA for environmental protection, Enterprise Ireland for new company generation, Fiat for integrating solar panels, and then kind of more specialist programs like Smart Top with solar panel integration, CODES-RES, which is an environmental protection program. I kind of get to change and work on different projects. They use my experience and skills and expertise in their specific project, and then it means I get to have a taste of different fields and different sectors as I go along and change quite quickly. But one of my favourite fields and one I do an awful lot of work in is in 3D printing. So I do an awful lot of 3D printing work, both research at a basic level, and then application of research, how we can make it better and how can we can apply it in the third world. So things like creating educational tools like the dinosaur skull, or manufacturing kind of low-cost prosthetic hands for kids and people like that. So we use an awful lot of stuff like that. There's a huge amount of 3D printing facilities on this campus in UCD, and we're one of the best in the country for facilities and technology when it comes to 3D printing. I also then work in a range of environmental protection. So issues like this is a huge global problem, plastic pollution and pollution in the environment. Like, it's a huge issue. It's still nowhere near been solved, but we're working on ways to try and reduce the amount of plastic that's in our environment that pollutes, kills animals, causes a huge amount of environmental issues. So I have some projects in that field looking on how to do things like that, and it ends up teaching stormtroopers how to make things out of plastic bottles. And a whole range of different things, but we're groups you wouldn't surprise. So there's an awful lot of movement of bringing practical skills back into application. If you want to try and tackle a problem in the third world or India or Africa or somewhere like that, a fully technological solution may not be applicable. They may not have the money, they may not have the power, they may not have the knowledge to do it. So practical solutions are kind of becoming more and more popular. So I'm working with groups like the United Nations Development Programme, European Commission, UNESCO project, and then individual projects that are about applying practical engineering skills and teaching regular people how to solve these kind of global based issues. I then work in VR and AR as well, so applying virtual and augmented reality systems to things they weren't before. So the little R2D2 thing was a tourism guide we made for Kerry County Council to do with Skellig Michael down in Kerry, to do with Star Wars and that sort of stuff. And any Star Wars fans know he had nothing to do with that island, but just let me away with it. I only found that out afterwards. It's not my fault. And then engagement and education. So adding augmented reality systems to environment, museums and technology. So you can go and digitally engage with museums. There's some done in Ireland, more done in the UK and the US, about how we can digitise and improve interaction in museums. So applying technology to a field that doesn't have a huge amount of it in currently. Similarly with drones, how you implement drones, data collection, 3D mapping, 3D imaging, issues to do with security, privacy, that sort of stuff, how we can help combat, how we can use the technology effectively and then combat some of the issues they currently face. And I do that in a way that isn't just sitting at a desk doing research reports, which you might think is with the research engineer. It's public talks. It's the catapult was for an education thing, teaching kids about physics in a way that's appealing by us firing giant rocks at televisions. And kids pay attention to physics when you throw a huge boulder at a television, surprisingly. And then public talks, public workshops, public engagement, everything involving the public, getting people to tackle these issues, understand them, get involved with them, and contribute to us solving these problems. I also started, while I was in UCD, a charitable foundation called the Rapid Foundation, and what we do is we distribute 3D printing technologies. So we raise money, we build hardware packs with 3D printers, computers, systems like that, and we distribute them around the world to developing regions. And those regions then apply them to solve whatever problems they need to solve. So in India, it's an awful lot of production of educational supplies, maps of India to teach kids about the regions in India. In Africa, we make a lot of medical devices, very simple kind of wrist braces and then more complicated prosthetics. In Rwanda, it was about encouraging girls to stay involved in science and technology and maths, using technology. You bring cool technology, you teach the people there how to use it, and people are interested in kind of, it lights a fire in them and they want to know more. We also do the same here in Ireland too. It's not just overseas, so we go to shows and events and we work with these displays, Dublin Maker Fair, sea festivals, coastal festivals, marine festivals, tech shows, that sort of stuff, just to get people hands-on, show people how 3D printing works, what they can do with it, or highlight issues with plastic waste, the value in it, what you can do with it, kind of a direct engagement, again, to distribute these technologies. And it worked really well and it's been really successful for us. We've won an awful lot of awards, we've worked with an awful lot of big groups from the United Nations Development Index, from Forbes and the JCI and Nissan, a huge whole host of different stuff. And for me personally, it's been really beneficial to do social good work, and it also benefits people individually. So anyone here that's interested in doing a for-profit startup company, forget about that. You want a non-profit social enterprise, they're the business. You can't fail with them. Everyone loves them. It's brilliant. Do one of them. And it gets you on things like this. So I'm a Nissan Generation Next ambassador, so I work as a brand ambassador for Nissan with some other great people. Adam Harris from the autism charity, Choopy that makes the jewellery. We've got tech developers, company developers, DJs, artists, that sort of stuff. And it means that I got a nice car from them to bring on research projects and research trips to kind of, this was us using a drone to image the coast of Achill Island a few months ago. So it's really interesting, it's involved, it's in the field, and it can be quite interesting. So I also do some lecturing as well, about in a range of different places. So here at UCD, in 3D printing and design, that sort of stuff, social engagement. And then in the US, Ireland, Malaysia, all around the world, all about active engagement and teaching people how to solve problems and real life issues with whatever they have, mainly using technology applications. But I also do them for groups you wouldn't expect. So this is like an early stage learning group, National Learning Network, people that are just getting back on the educational ladder after disabilities or injuries or years away. And we do digitisation, 3D printing and creativity workshops with them. So it's really, really, really useful. I do some consultancy work on the side in a range of different projects, from oil and gas projects in Russia to consumer product design in Silicon Valley to consulting with airlines on the future of airlines in Malaysia. So a whole broad spectrum of stuff, from commercial, non-commercial, for-profit, non-profit, that sort of stuff. It's nice, it keeps it interesting, it keeps it varied. And again, it's very active, very engaged, an awful lot of group work, an awful lot of group involvement, the applications of technology. It's nice. I'm also kind of entrepreneur, so I've had a couple of technology companies in the past. Some have worked, some hasn't, that's the way it goes. In 3D printing, biofuel generation, I've been a founder and an advisor to a whole range of different companies, creating third world habitation shelters to apps for improving your golf game, anything and everything. So engineers make the best entrepreneurs you can imagine. People fall over themselves to get engineers involved in startup companies. Most of the Fortune 500 companies, their CEO or founder is from an engineering background. So if you'd want to do business, engineering is the way forward to be better at business than the business people. So no offense to them, but it's true. And then I'm very active in the technology community, and this is globally, with things like Startup Weekends, Dublin Startup Week, X Prize, Future Scope. The technology sector is like bubbling in Ireland at the moment. There's jobs everywhere, there's opportunity everywhere. It will probably be that way for the next 10 years at least, with technology and startups and innovation and investment. So there's a huge amount of interest and excitement in the technology space, and they're crying out for engineers. More engineers are needed by every company, in every field, at every stage. And then you do public events exactly like this one. So it might be discussion panels on the future of design with people from Accenture, or it could be technical engagement or public outreach things about third world development and technology development overseas. So as you can see in all of them pictures, not any one of them do you ever see me wearing a suit. So it's not what I do. But they're engaged, they're bright, they're colourful, they're open, they're inclusive, they're for everybody, no matter age, gender, religion, location, it doesn't matter. It's open, the tech field is wide open, very engaged, very interesting, very different. I'm also finishing my PhD, so I've tied a PhD together to put all of this sort of work together. So my PhD will be finished in September. Everybody pray for me. It'll be finished in September, and this is with a group in UCD called Smart Lab, funded by the Irish Research Council and Science Gallery. They have one in Trinity, and what I'm doing with them is innovation methodologies, creating guides, methods and systems to help everyone innovate better using technology. From you guys here to orphans living in an orphanage in India. Technology is available, we can solve all the world's problems with it, we just need to find new, more effective ways to do it. And my favourite thing so far has been this. So this is Ella, so Ella's, I think she's 7 now. She was 6 at that stage, or 5 at that stage, and she was born without any fingers on her right hand. So the health system here in Ireland said they wouldn't give her a prosthetic hand until she turned 18, because she'd grow too quickly and the hand is expensive, which is an excuse. So we decided we'd do something about it. So we managed to 3D printer this prosthetic, open source, free, available. I can email the files anywhere to anybody. We managed to make the hand for, I think it was about €10 versus a couple of €1,000, and we gave her a hand. And within like 10 minutes of fixing it, she could pick up bottles, she could kind of pick things up off the floor, she could play with her doll. And it was like really had a huge impact on her life, so much so that when she went to leave, she went to open the door with the hand she didn't have 10 minutes ago, which, if anyone works in the medical field, is unheard of for fitting prosthetics. So engineering and technology and the things I've done at UCD has allowed me to do this. I would do this all day, every day, I try to do it all day, every day. And these are the sort of things you can do with engineering. It allows me to travel an awful lot. Travel is excellent. It broadens the mind. It's very enjoyable. And engineers travel regularly to every corner of the world to work on every project you can imagine. You can do as much or as little as you want. You get to a stage where you do enough of it and you don't really want to do any more. But that happens. From what I do, I lead most of my own projects, so I decide what gets done. The buck stops with me, so if I'm lazy and I don't do anything, that's my fault. It's my head on the block. But it lets you kind of structure your day differently. You get to work, design your own plans, and then take full ownership of what you want to do. And that was my kind of path. It was a little bit different. The road less travelled from a poem that people more intelligent than me will know what that's from. And yeah, it's nice. So that's what I'd encourage you to do. Kind of explore these alternate roads. Take these paths that aren't hugely travelled by others. Technology's changing. There's a huge whole host of jobs that you guys will work in that don't exist yet. Technologies that'll change the world are in your minds or in someone else's minds. They're not out there yet. So take the kind of alternate path, take the technologies that aren't there yet and be the ones to explore the less travelled road and create the world that we're going to go in. From that, find your passion in whatever it is. Mine has always been in mechanical engineering. Now I've pivoted, I got fully qualified in automotive technologies and then have never worked in automotive technologies. Stuff happens. So you can do it, but once you're interested in it, I love engineering, I love the problems I work on, I love solving these solutions. Once you're passionate about what you want to do, it's the cliched saying is you'll never work a day in your life, but it's true. As you can see, for me it's like play, it's engagement. If I wasn't doing it professionally, I'd be doing it personally. So once you do that, you live quite a good life and it's happy, you're engaged together. So that's what I'd say, kind of to echo what was said before. If you're a problem solver, if you like maths, and notice I said if you don't have to be brilliant at maths. I wasn't, but once you like it, you're not afraid of it, you're willing to learn it. You're creative and innovative, with an awful lot of people wrongly do not associate with engineering. If you want to change the world for the better, apply new technologies, solve some of the issues, global warming, renewable energy, marine waste, global waste, whatever it may be. And then if you'd like an exciting or interesting career. So I'll be here afterwards. We're going to do question and answer sessions and I'll be outside afterwards if anyone have any questions for me. And my voice stops. So thank you for listening, and I think we go to David for the panel.
Thank you very much, Colin, and that's why 2 years ago Colin was nominated as one of the 30 under 30 in Forbes magazine. So I'm not quite sure how he's going to get his PhD done by September if he's still doing everything else, but that's where the time management piece comes in, I guess. So as my colleagues have mentioned, they are around for one-on-one chats if you want to talk afterwards. We have time for some general questions if there are any general questions. Otherwise, we'll make time to meet with you individually. So. Are there any questions from the audience? Nope? Okay, listen, thank you very much for coming. Feel free